Our next speaker is Mr. Anupam Jain. Sir is founder and principal for Rationality Design, and welcome, sir.
Thank you, sir. Okay, so hi and good afternoon. My name is Anupam Jain. I am an architect, and I always think that civil engineers are smarter than architects. Yeah? All right. So now that I'm already your favorite, how many of you can actually design a green building? Yeah? Yes, one person can. 2.5. One is like that. So he's like, I am there, but I was just scratching my head, if I call on that person. So I call on you, sir. He knows which one, he knows. All right, so we have since morning, I believe, heard a lot about the importance of green building, and I'm sure you've heard that a lot from your professors as well. In almost all subjects, do we tell you, no, this is not required, Do we ever say that? We always say that, okay, green building is required, build sustainably, save the resources, save water, save energy, save concrete. Maybe not. Maybe save some reinforcement here and there, but you want to make the building strong and seismic compliant, right? And when we talk about a green building, what exactly is a green building? Can I have this interactive? Can we do that? Are you loud enough? All right. So let's just do a little small exercise. When I say a green building, I'm not saying sustainable. Out. Green building. What does a green building mean to you? One word. Yes, ma'am. Eco-friendly. Economics. Economical. Okay. Energy efficient. Yes, sir. Energy conserving, sustainable. All right, I'm going to roll up my sleeves now. And what else? Sorry? Come on. Okay. You talk about any green building rating system, right? So when we talk about any green building rating system, even IGBC has like more than a dozen now, right? More than a dozen rating systems. There are principally, 5 categories. One is sustainable site, which means that the site on which you're making your building is important, right? It is, to some extent, tiny bit, but it is. It's one of the most important categories. Then comes water, energy in atmosphere, or energy efficiency, or water resource management, or water efficiency. And third is what? Indoor environmental quality, and you have materials and resources. And then we have the 6th and 7th and so on, which is innovation in design and innovation in operations, depending whether it is a design rating system or an operations rating system. And then we have a new category called location and transportation, which is in addition to the site category. So there are a lot of documentation, there's a lot of documentation which is required to document a building which is green, right? But the most important aspect is what is it that we are documenting. We have now understood that it is important to make a building green, it is important to build sustainably. We cannot do without it. The survival of the future generations, for me it is you, right? Depends on that. Can you say that, okay, so we have a tank and it has only enough water for, you and your roommate to take a shower, right? And then you have a guest So what do you tell the guest? No, you are a guest, sorry. Can you do that? No, right? Well, you might say, I don't want a shower, you go and take a shower, right? That's also possible. That's hostel life. But really, that's the case. That's the case. The resources are limited, whether it is all the finite natural resources that we once thought were infinite, includes all the coal from which we get our electricity, right? And the water. We thought we have infinite amount of water, right? But only 1% is drinking water. And you know the case of the Middle East. They are surrounded by water, and water everywhere. Not a drop to drink. So they have these energy guzzling desalination plants, where they desalinate the water, remove the salts, remove the impurities, and at a very expensive, hit to the exchequer, they generate water which is then supplied almost free to everybody. What happens when you get something for free? You waste it. Yes, you waste it. If I gave you something and I charged a large sum of money from you, then you will be like, no, this is something which I am going to write in my will. Very precious. I am going to keep it in my locker, right? So that's one aspect, that resources are finite and one needs to conserve them, and whatever documentation you are doing for the things which make a building green, those are the real things. Those are the things that you need to understand as technical professionals who will be entering the profession. Some of you, can I see the fourth years? Fourth years, they're all gone. One guy, 4, 5 here. All right, a few there, people are waking up. Yes, you're awake. So, you guys are going to enter the industry. Job lag gaya? Sorry. What happens in a job interview? So I am repeatedly getting calls from placement cells of different colleges. We want to place our students with you, and my professors, they call me and they say, Anupam, you should, this is our best student. This is really, literally, this is our best student. Please take them under your wing and help shape the career. All right? I call the student next day for an interview. And what I see is that they want money, but they don't want to do the work. Or rather, they don't know what to do. They don't know how to work. That should not be the problem. You are here, you are spending 4 years of your life training yourself to do the work, right? So if somebody asked you that, can you design the structure of my building? You should be able to do that, right? But does anybody ask you that anymore? A lot is expected from a civil engineer. You're not just that person in your family who everybody approaches and says, yaar, ye chhajja extend karna hai. Can you tell me, is this wall going to crumble? You're a civil engineer, come on, you should tell me. How can I get this, balcony extended? How is this foundation correct? You're more than that. And when you are working on these modern industry projects, right? What is the role that you are expected to have? Site engineer? Yeah? Have you heard of this term before, site engineer? You should be very scared of that term. Do you know what a site engineer does? Stands for the whole day. Yes, great. What else? Sorry? Burns himself in the sunlight, stands for the whole day. Sounds like a traffic cop to me. But the kind that cannot even challan somebody. site engineer usually ends up being, you know, a person like you when you graduate and you enter the field and you are appointed the site engineer. I have seen a lot of my students, 3 of them are here, and they go back, you know, they come back from the internship and they, you know, they come back complaining that while in college, while in class, they're always very, you know, excited about site visits. Sir, we want to go to site. Do you guys do that? Yes, sir. You do that, right? And then when you finally do go to the site and that's your new home, you don't want to be in that new home. You want to run back. Sir, please take us back into college. Hum yahi achhe the. Why? What happened? We were standing on site, our supervisor doesn't like us, and what is our job description? We have to supervise labor on site. Who is working? So what are you doing? Sir, I'm just making sure that guy is laying the tiles correctly, he is doing the, you know, woodwork correctly, I'm just making sure he's picking up the malba correctly. At least he's working. What are you doing? Sir, even I don't know, sir. That guy hates me. I'm standing on his head the whole day and telling him how to do his job. He knows better than me and he hates me. And when I go to the supervisor and tell them, you can do this, you can do this, you know, project management, you can do this, you know, analysis, you can do this report, they don't want to take orders from me. They don't want to know how to do, you know, their job from me. So what happens is that people tend to specialize. In order for you to carve your own niche, you have to specialize into some aspect of the construction process, right? And green buildings gives you that sort of an alternate. It's not the alternate. There are many paths you can take, right? You can become a cost estimator, you can become a valuer, you can become a green building expert, you can become a project manager, you can become the master, you know, purchase manager. You can become a lot of things. And one of the things you can specialize in is green building. And that is a very, you know, evolved sort of a field, and evolved because now you are telling not the, you know, labor on how to do their job, but now you are telling the architect, the MEP engineer. MEP everybody understands? Mechanical, electrical and plumbing, right? So the mechanical engineer, the electrical engineer, the plumbing engineer, the contractor, even the owner, you are telling them that as per a comprehensive third party rating system, these are the documentation requirements. That's one. But more than that, you are telling them how to design. So Mr. Mahajan, who just spoke before me, he was telling his experience on a project where the green building facilitator recommended some changes in the design and how they talked about having some overhangs, right? And how that impacted the energy score, energy consumption. So who are we talking to over here? Who is the green building facilitator saying these things to? Which member of the design team would do that? Contractor, right? Or the electrical engineer? No, it should be the plumbing engineer, right? It is the architect. What does the architect do? Design. The architect, okay, this guy is a little bit less in majority, less in number over here, so I'll represent the architect. So the architect does the design, and he is responsible for the projections, overhangs, the look and feel of the building, right? So as a technical expert in green building, when you are able to establish that, okay, if I shade my windows by means of an overhang, a balcony or some chhajja, then I am not letting the solar heat gain enter the building, and that will potentially reduce the air conditioning load. and if the air conditioning load is decreased in a hot climate or in a composite climate, you will save electricity, you will save energy for air conditioning, right? So you are in a way giving a palette of options to the architect that, hey, architect says, hey, this is what I can make, you know. And then it is up to you to technically say that, okay, no, if you make an overhang which is 1 meter in depth, that will exactly meet my requirements of shading the building at these critical times of the day and year, and that's why your overhang should be this wide. Similarly, I'll give you an example. So I was working on a project where we were designing you know, sort of an assembly area, where this is an assembly area, right? An auditorium. And the National Building Code of India, you guys heard of it? That says that you have to have 45 liters per person per day for flushing, right? 45 liters. And the plumbing engineer came back on the project with exactly that kind of a you know, calculation, with that number. And the only problem was that it was a 50,000 seating and 1 lakh people standing. So at a time 1,50,000 people would be there in the building, and that resulted in a tank which was bigger than the building. That was the only small problem. And he presented the, you know, layout in front of the entire design team. All the different representatives of the design team are sitting across the table, and he rolls out his grand tank, right? And I'm the only guy laughing, you know, and people are like, they ignore me. They're like, must be crazy, you know. And I'm like, are you guys crazy? They're like, why? I'm like, your tank is bigger than your building. And they now look at the plumbing engineer. And plumbing engineer is like, no, don't look at me, NBC. NBC says 45 liters. So as per 45 liters, this is the tank. And I said, okay, give me a day or two and let me redesign this thing, right? Okay, very simple quiz. Can somebody tell me, when you go to the washroom, everybody's been to the washroom, right? So when you go to the washroom and you press the flush, how much water comes out? Can I have a show of hands? Does anybody know? 45 liters, 20 liters, 8 liters, 6 liter, 4 liter, 4 going 1. No, is there somebody lower than that? 4 to 5 liters, 5 to 10 liters. It's amazing, nobody knows. You go to the washroom every day, right? 5, 4. Huh? Can't hear you. 3 to 5 liters. 8 to 12. We can excuse this guy is not even an engineer. हाँ 13 लीटर कहीं ना कहीं से तो कैलकुलेट हुआ है 13 liters and it has come after a while, so somebody has been calculating. So 13 liters, from 40 liters we have come to 13 liters and 4 to 5 and 3 to 5. Most of the WCs, water closets, the toilet, right, now come with a dual flush which is 3 and 6. 3 if you take a piss and 6 if you take a dump, right? That's the standard. And if you go by that, now if you look at a green building rating system, a green building rating system will tell you exactly one person going to take a dump once a day, going to take a piss twice a day, male separate, female separate, urinal is going to take this much water, WC is going to take this much water. So in a very scientific manner, they are going to estimate the total water requirement for a building, which is now the baseline. So they are going to use codes such as the Uniform Plumbing Code of India, and different rating systems have their own baseline numbers given in the standard itself, which talk about how to calculate how much water is actually going to be used, and surprisingly it is less than half of 45 liters. It is much less than even half of 45 liters, right? And then all that flushing water, this particular site that I was talking about, this particular design team meeting, we were on a site where we had a large landscape area. So we took all the flushing water, we reduced the water per head based on these calculations, right? Anybody can do these calculations. Anybody who understands these numbers can do these calculations. On these calculations, we said, okay, it's not going to be 45 on this criteria, on the basis of these codes. This is the amount of water that is realistically being used or going to be used by one person in the entire place. So this is the total water which is expected to be flushed even if you are at peak capacity. What is it making sense what I am saying? Yes, right? And now whatever water you have collected in your sewage treatment plant, that everybody knows, right? All civil engineers know this sewage treatment plant. Okay. So, and that STP is going to throw some recycled water out which can be reused in the landscape. So we created a big water body on the site and utilized most of the recycled water in the water body. The tank became, a tenth of its size. Can you imagine the cost implications? This tank we are talking about is typically made in the basement. It's below the ground, which means it is an RCC tank. It has got waterproofing. It's going to leak. It needs all sorts of pumps and valves and all sorts of machinery, all sorts of operations and maintenance, right? All of that is becoming 1/10. That's a huge saving. That's a huge saving. Another example I'll share with you. Now, I've shared with you the water part. I'm just sharing these examples with you because you can be that person who can do these calculations. Doesn't need any gray hair, just needs intelligence, and you are plenty intelligent. You just need to apply yourselves to that level of calculations and learn that. In another project, so this is on NH8 in Gurgaon, and we were making a commercial office building where the client invested about 1 crore of rupees in making the civil structure of the office building, and they were wanting to make it a green building. So we were appointed as a green building consultant, and I get a call from the owner, and the owner is calling me to save money, right? So he tells me that, Anupam, my mechanical engineer is telling me that I have to put a central air conditioning system which is much more efficient than any other air conditioning system, and I have to do that because I am making a green building. I have to get more efficient air conditioning equipment, and that, by the way, is costing me 1 crore more. So in the cost that I made my entire building, I have to now install I have to invest the same amount of money to cool that building. That's ridiculous. And he is saying that because it's a green building. You are my green building consultant. Is that right? So I'm like, okay, let me, again, give me a day or two. Let me look at the calculations. Let me look at what the engineer has done, right? And after 1 hour, I give a call back to the owner and I tell them that you can fire your mechanical engineer. and you can save the full 1 crore. And he's obviously very interested to know more, right? It's like zero investment, no money required, fully air conditioned building. Like, tell me more, right? So the purpose of the owner in making the building was that he wanted to rent out floors. He wanted to make this building of 10 floors and rent out these floors to MNCs, right? He was giving a bare shell building with no flooring done, no false ceiling done, only the firefighting things are there, that's all. The air conditioning will be provided later. So I tell him that why don't you do one small change in your architecture, and on every floor just make one balcony on one side, and we are going to install ductable split air conditioning units, and we are going to keep all the outdoor units in that balcony. Whenever any one of your floors is getting rented out, how do you operate? If you go to rent a place, do you pay advance? You pay some advance, right? And you pay some security, right? So you typically pay 1 month security. In commercial, it's about 2 to 3 months of security, right? So let's say I am charging a rent of about 5 lakh rupees per month for one floor, and I'm taking the advance rental for 2 months, the security for 2 months and advance rental for 1 month. That means I have 15 lakh rupees. 5 into 3, 15 lakh rupees I am going to get upfront payment from every floor. When I get that 15 lakh rupees, can I at that point not just go and invest that money into the air conditioning system for that one particular floor? Just buy the ductable outdoor split units, install them, and there you are. It will be done in less than 15 lakhs. So whoever is renting the floor is actually coming with the payment for installing the air conditioning. Guess what happened to the mechanical engineer when the owner got this logic? He was gone. History. I'll share with you another example. I went to the headquarters of a school chain, right? They have a lot of schools. And they called me to their headquarters and they said, we are the corporate office of this big school chain. This is our office. And we were having a discussion on one of their school buildings. We did all of that. And then the owner said, by the way, the building in which we are sitting right now, we get a huge electricity bill. So since you are the green guy, you bleed green, right? So my students often joke about that, by the way. They're like, if you cut Anupam Jain, you'll find green. So, he said, can you come, another day and just take a look at our building? I'm just paying through the nose, I'm paying a lot of money every month just to, get the lights on. Electricity bill is so high. So I come back another day, I live close by, so I go back another day, and what I discover is that on the rooftop there are a lot of outdoor units, lot of mechanical engineering, lot of mechanical engineering happening, lot of ductable splits happening, lot of outdoor units happening, just like you have an outdoor unit for your normal split air conditioner at home, right? You have a bigger outdoor unit which is kept outside on the roof or balcony, whatever. And so lot of outdoor units littered all over the roof, and the entire building is air conditioned. So then after doing my field visit, I go and meet the owner, and I ask him, so sir, where did you get this air conditioning designed from? And the owner was like, he's very happy, he's very proud. So he tells me, all these engineers, it's a waste of money. Never hire these engineers. So why? What happened? They'll ask you for a lot of money for things which are available for free in the market. What do you mean? Just take this air conditioning for example. You were telling me that this air conditioning, who designed it? Well, I have a guy, and he works with whatever air conditioning company. He designed the system for me for free. free, free, free. Didn't charge me a single penny, and he produced the most detailed drawings that even these mechanical engineers cannot produce, and he did all of that for free. And see, I've got it all installed. So then I told him, sir, that guy who did design the engineering, the entire air conditioning for you, he has air conditioned your plumbing and electrical shafts also. Now all your shafts, even your garbage chute is air conditioned. So that's the difference between that free guy, because he's going to design all of these things for free, because he's going to put a lot more air conditioning than you need, so that you buy more and more and more of his products. Whereas an engineer, the consultant, one of you guys, is not going to do that. You're going to be that impartial third party who is going to look at what spaces need to be designed air conditioning for and what don't, and that is your value. So with that, I would like to conclude. Please get into the calculations, try to understand how to make a green building. You now know a lot about why it is required. I believe you all agree with that. But those who are serious in specializing in green buildings, in making a contribution at the design table, they need to understand how to actually do the calculations and how to add value to the project. So with that, I rest my case. Thank you so much.